Okay, so today I want to talk about distance versus displacement, which is my first um, topic when we talk about motion. Okay, we have two different quantities here. We've got our scalar quantity. Oops. Scalar quantity, which means a number or value without a direction. So I might say I walked 100 meters today. I might also say the car was going 25 meters per second. Um, Regardless of what it is, scalar just means it does not include a direction. Vector, on the other hand, is where we have a value, a number, but you also have that direction right there. So when you include a vector, it must also include the direction. Um, for example, I might say I ran 100 meters south, or the car is going 25 meters per second to the right. Regardless of what it is, you need to make sure if it wants a vector that it has to be in a direction. You have to include that direction. If you do not include a direction, um, then it is scalar and not a vector anymore. So going along with scalar and vector, we have displacement. Displacement describes the distance an object moves in a specific direction. So we're looking at the point we started to the point we stopped. How far away are we from each other? Um, and it's a little different than thinking about distance. Um, a, we have to include a direction when we talk about displacement. B, we are just looking from point A to point B. You may take a road from this dot here. You may go up and down and maybe do a loop de loo, all in order to get back to this point. Okay, so the distance was the up and down loop de loo. That would be distance. But the displacement is actually how far it is from the starting point to the ending point. So I would say, I don't know how far that is. We'll say 5 centimeters down or 5 centimeters south would be my displacement there. Let's do an example. Clyde rides his scooter 50 meters down the sidewalk from his house. Then he turns around and he rides his scooter the 50 meters back to his house. What's the distance he traveled? What is the total displacement? So let's look. Let me try to pull up a fresh sheet here. Oops, nope, I didn't mean to do that. Let's go right there. Okay, so here, beautiful house that Clyde is living in. So beautiful. Okay, he gets on a scooter and he goes 50 meters in that direction. So 50. Oop, I can't draw with this thing. Then he gets back on his scooter and he goes 50 meters back. It's a little better, still pretty crazy. So he went 50 meters out, 50 meters back. His total distance is going to be what? You go 50 plus 50. His total distance is going to be 100 meters. What is his displacement from start to finish? His displacement is a 0. He has not moved. He did move, but his start and finish points are the same exact spot. So therefore, we can say his displacement, even though he's probably worn out and tired and did a lot of work, his displacement is 0 because he ended up exactly where he started. And is the only time. My eraser not working. That is the only time when we can use a number without actually including a direction there. Okay, I don't know why this is not working here. We want to just do this. Scroll down a little bit. Okay, so let's look here. Let's say we're back at Clyde's house. So we're going to draw his house again. This time he's painted it. It's a little magenta instead of red. So there's his house. And he takes off on a scooter and he's going 50 meters. And then, so let's do 50. And then he gets back on a scooter, goes home, and makes it halfway before he has a massive cramp in his leg. So he's going 25 meters back. So how many meters has he traveled in total? So what was his distance? We know he went 50 this way, 25 back. His distance would be 75 meters. But what is his displacement? Look at where he started, which he started right here. Look at where he finished, which was this point right here. And if we look at those 2 points, the distance in between, we can do this one in our head, but 50 minus 25, what's left over? Our displacement is going to be 25 meters. Now, this is where it gets a little confusing because you need to think, are you moving, is he to the east? So we got north, south, west, east. So is his displacement to the east or to the west? Well, he started here, and now he is farther to the east. So we know his displacement is 25 meters to the east. And that is distance versus displacement.